How are you, my friends? This is another video on basic math terms, vertical and horizontal tangents, and we will see the meaning of cusp. This is part 33. Just to remind you, please, part 30 was the start of Calculus 1 terms and the algebra terms, parts 1 to 18, pre-calculus terms, parts 19 to 27, and statistics terms, parts 28 and 29. Let's go back to our video today, part 33. These are the terms: generalized power rule. We have seen that also, just to stress the idea. Differentiability definition, vertical tangents, horizontal tangents, cusp, and sharp corner. Let's see the generalized power rule we have mentioned before. The derivative of a function, we have g of x all to the power n. So we can bring the n down times g of x to the power n minus 1 times the derivative of the function inside, which is g prime of x. And this is one example on generalized power rule. If we need the derivative of square root of 50 minus 7x cubed, we can rewrite all this as 50 minus 7x cubed all to the power half. So we can use exactly generalized power rule. Now the function inside here, g, is 50 minus 7x cubed. So to find the derivative of this, bring the power here, which is half. 50 minus 7x cubed to the power half minus 1, according to the formula, times the derivative of the inside, 50 minus 7x cubed prime. So half, we bring it here down. Half minus 1 is minus half. The derivative of 50 is 0. And minus 7x cubed, the derivative will be minus 21x squared. Simplify everything. You will get minus 21x squared divided by 2, square root of 50 minus 7x cubed. I can bring this power minus half. In the denominator will be power half, and power half is the square root. So that's an example here. Differentiability means we have f prime at a is equal to the limit of f of a plus h minus f of a divided by h as h goes to 0 whenever the limit exists. So we call the function is differentiable at the point A. Vertical and horizontal tangents. Let me start with the horizontal tangent, which is easier. Horizontal tangents, you find the derivative of the function. Put f prime is equal to 0. Then find the values of the x. So at these values, then you have the horizontal tangent. Now, when do we have a vertical tangent? At the point A, f of a, f is continuous, and also the limit of f prime, see f prime here is the derivative, limit of f prime as x goes to a from the right, or the limit of f prime as x goes to a from the left is equal plus infinity, or both limits are equal to minus infinity, then we have a vertical tangent. We will see an example, or you can go to the lecture of Cusp. Nice example here. Find all the points on the graph of the function f of x, x square root of 2 minus x, where the tangent line is either horizontal or vertical. So we have a horizontal tangent and we have a vertical tangent. Let's find the values of the x. So for sure we start to find the derivative. This is Calculus 1 lecture number 9. This is the function. Find the derivative. There is a product rule. You can check it, please. So the derivative will be 4 minus 3x divided by 2 square root of 2 minus x. Okay. Now, the horizontal tangent is the easier. Put f prime is equal to 0. See, when you put all this is equal to 0, that means the numerator, 4 minus 3x is equal to 0, so x will be 4 over 3. This is the x value. How to find the y? Put this x in the function here. F of 4 over 3 will be 4 over 3 square root of 2 minus 4 over 3, which is 4 square root of 6 divided by 9. So the function of the graph has a horizontal tangent at the point 4 over 3, this is from the x, and 4 square root of 6 divided by 9. Let's see where the function has a vertical tangent. Vertical tangent occurs when f prime is undefined. You can see that here. This is f prime. When it is undefined at x equals 2. So we need now the image f of 2. Put 2 in the function. You get 2 square root of 2 minus 2, which is 0. So the vertical tangent for this function at 2, 0. One horizontal, one vertical. Now, what is a cusp? Vertical cusp or cusp? If the tangent is vertical to the graph, then the function has a vertical tangent. Now, a special case of a vertical tangent, we call it cusp. Vertical tangent, if it divides the shape of the function into two portions back to back. We will see two examples here. Then the function is said to have a cusp. So in mathematics, a cusp is a point on a curve where a moving point must reverse direction. I will explain also that in the graph. So y equals f of x has a vertical cusp in two cases. If we have the limit of f prime as x goes to a from the left is equal plus infinity, and the limit of f prime as x goes to a from the right side is equal minus infinity. See, this is opposite. Or we have the limit of f prime of x as x goes to a from the negative, it will be minus infinity, and the other one will be plus infinity. Let me show you one nice, easy example on cusp. This is the function x to the power 2 over 5, and this is the graph. Let's find f prime. Easily, we can use power rule. 2 over 5, fifth root of x cubed. Now, where is f prime? Is undefined at 0. So function is not differentiable at 0. Let's check now the limit. Limit of f prime, this is f prime here, x goes to 0 from the right side. From the right side, it will be always positive, so it will be plus infinity. From the left side, it's minus infinity. See, the right and left limit of the derivative do not exist and not equal also. So this one, the function has a cusp. You see, now if you are moving here, you see this direction? If you continue, that means not cusp, it's a vertical tangent. If you continue, then you reverse. See, the point is moving here, then you must reverse. You see this one here? They will reverse direction. So we call it vertical cusp. Now here I will put 4 cases where the derivative fails to exist. We can have discontinuity, so the function is not differentiable. We can have cusp. See, the graph is coming this way, and then it must reverse direction. Look here down, just a vertical tangent. See, the graph is going this way, and it will continue. It's not reversing direction. Sharp corner, when the limit on the right is not equal to the limit from the left. So the function is not differentiable. We call it sharp corner. So sharp corner, the function is not differentiable. At cusp, the function is not differentiable. Vertical tangent, the function is not differentiable. And if we have any discontinuity, the function is not differentiable. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.